Hello students, welcome to online lecture on fluid power systems. Students, in last class we have discussed about the contents of all 5 modules, components of pneumatic system, components of hydraulic system, advantages of fluid power systems, application of fluid power systems, Pascal's law. So in this lecture we will go through the working of the hydraulic system. So first we will start with a working of hydraulic system. So reservoir is used to store the oil. The pump is connected to the reservoir. The pump delivery is connected to the pressure relief valve. From pressure relief valve, the oil is going to move to direction control valve, and from direction control valve, it will move to the actuator. So high pressure oil, when it enters the actuator is going to extend and it is going to do the work, and we are going to get the work done in the actuator. After completing the work in the actuator, the oil is going to return to the reservoir. So in first position of the valve, the actuator is going to extend. In center position there is no movement of the actuator, and in the third position the actuator is going to retract. So in simple sketch we will discuss the change of position of the direction control valve. So here we can see a reservoir, a pump, direction control valve and actuator. In one position of valve, P and B are connected. When P and B are connected, the cylinder is going to extend. At that time A and T are connected. The oil which is filled on the other side, it is moving towards the reservoir, and oil which is pumped, it is moving towards the actuator, passing through the ports P and B. So in another position of the valve, P is connected to A and B is connected to T. So at that time the cylinder is going to retract. After doing the work, it has to retract to its original position. So this is a simple sketch. Here we have shown a reservoir which is used to store the oil, pump, direction control valve and actuator, and we have discussed 2 positions of the direction control valve. Next we will discuss the transmission of power at static and dynamic states. Any hydraulic drive that can translate its pressure into mechanical output may be termed as a hydrostatic machine. Any hydraulic drive that can translate its pressure into mechanical output may be termed as hydrostatic machine. A hydrostatic system uses fluid pressure to transmit power. Hydrostatic deals with the mechanics of still fluids and uses the theory of equilibrium condition. In fluid, the system creates high pressure, and through a transmission line and a control element, this pressure drives an actuator. The actuator may be a linear type or it may be a rotational type. The pump used in hydrostatic system is a positive displacement pump. An example of pure hydrostatic is the transfer of forces in hydraulics. A simple hydraulic press is a good practical example of a hydrostatic device. Hydrodynamic systems use fluid motion to transmit power. Power is transmitted by the kinetic energy of the fluid. Hydrodynamics deals with the mechanics of moving fluids and uses flow theory. The pump used in hydrodynamic system is a non-positive displacement pump. An example of pure hydrodynamics is the conversion of flow energy in turbines in hydroelectric power plants. In hydraulics, we deal mostly with the fluid working in a confined system, that is a hydrostatic system. Selection of hydraulic fluids. A hydraulic fluid has the following four primary functions. It is used to transmit the power, lubricate the moving parts, seal clearances between mating parts, dissipate heat. So the fluid which is used in the fluid power systems has four functions, that is, it will transmit the power, lubricate the moving parts, seal clearances, dissipate heat. In addition, a hydraulic fluid must be inexpensive and readily available. From the selection point of view, a hydraulic fluid should have the following properties: good lubricity, ideal viscosity, chemical stability, compatibility with system materials, high degree of incompressibility, it must be fire resistance, good heat transfer capability, it must have low density, it must resist foam formation, it must be non-toxic. This is a challenging list, and no single hydraulic fluid possesses all these desirable properties. The fluid power designer must select the fluid that is closest to being ideal overall for particular application. To improve the properties of the fluid, we are going to add some additives to change the properties of the fluid so that it must work in atmospheric conditions at low temperatures, or in maybe medium temperature, or it may be high temperatures. So by adding the additives, we are going to change the properties of the fluids. So various additives are added to the fluid to sustain the important characteristics. Few such additives are anti-foaming. They are added to reduce foaming of fluid. Anti-wear resistance chemicals are added to the fluid to protect critical hydraulic components from wear. Corrosion inhibitors. Chemicals are added to protect surfaces from chemical attack by water. Biocides, emulsifying chemicals are added to the fluid to inhibit growth of waterborne bacteria. Emulsifier, these are added to facilitate formation and stabilization of an emulsion. Lubrication cleanliness agents. Extreme pressure agents are added to the fluid to enhance lubrication characteristics for effective full-time boundary lubrication between the mating parts. Flowlubricants. Chemicals added to dispersion of solids in a liquid to combine fine particles to form foil of small solid masses in the fluid. Deionization. Elements which provide hardness like calcium, magnesium, iron and aluminum salts are removed through deionization of the water. Oxidation inhibitors. Antioxidation additives are added to provide antioxidation characteristics. Oxidation changes the chemical characteristics of the fluid. Vapor phase inhibitor. Prevention of oxidation or corrosion of metals in contact with the vapor phase of the fluid is ensured by addition of appropriate chemicals. Effect of temperature and pressure on hydraulic fluid. Viscosity is the most important property of hydraulic fluid. Temperature has an adverse effect on the viscosity of the hydraulic oil. Hence, it has to be seen that the operating temperature of a hydraulic system is kept at a reasonably constant level. Otherwise, there will be tremendous issues in the system which will reduce the overall efficiency. A hydraulic fluid that is too viscous generates more friction and heat and usually causes high pressure drop, sluggish operation, low mechanical efficiency and higher power consumption. On the other hand, low viscosity fluids permit efficient low drag operation but tend to increase wear, reduce volumetric efficiency and promote leakages. Seals. The seal is an agent which prevents leakage of oil from hydraulic elements and protects the system from dust and dirt. The major function of the seal is to maintain pressure, prevent loss of fluid from the system and to keep out contamination in the system to enhance its working life and functional reliability over a longer period. So we will see the classification of seals, how to classify the seals. According to the method of sealing, they are classified according to the method of sealing. So first is positive sealing. A positive seal prevents even a minute amount of oil from getting past. A positive seal does not allow any leakage whatsoever. It may be external or internal. Non-positive sealing. A non-positive seals allow a small amount of internal leakage, such as a clearances of the piston to provide a lubrication film. So it will provide the lubrication film according to the relative motion existing between the seals and other parts. So they are static seals. These are used between mating parts that do not move relative to one another. These are used between mating parts that do not move relative to one another. These are relatively simple. They are essentially non-wearing and usually trouble-free if assembled properly. So another is dynamic seals. These are assembled between mating parts that move relative to each other. Hence, dynamic seals are subjected to wear because one of the mating parts rubs against the seal. So according to geometrical cross section, first one is O-rings. O-ring is the most widely used seal for hydraulic system. It is molded synthetic rubber seal that has a round cross section in its free state. O-ring can be used for the most static and dynamic conditions. It gives effective sealing through a wide range of pressures, temperature and movements. So here the cross section of the oil seal is circle. So next one is V seals and U-ring seals. V and U-ring seals are compression type seals used in virtually all types of reciprocating motion applications. These include piston rods and piston seals in pneumatic and hydraulic cylinders, press rank jacks and seals on plungers and piston. T-ring seal. T-ring seal is a dynamic seal that is extensively used to seal cylinder piston rods and other reciprocating parts. It is made of synthetic rubber molded in the shape of cross section T and reinforced by backup rings on either side. The sealing edge is rounded and seals. So here you can see the cross section of the ring is T. Piston cup packings. Piston cup packings are designed specially for pistons in reciprocating pumps and pneumatic and hydraulic cylinders. They offer the best service life for this type of application. Require a minimum recess space and minimum recess machining and can be installed easily and quickly. Piston rings. Piston rings are seals that are universally used for cylinder pistons. Piston rings offer sustainably less opposition to motion than synthetic rubber seals. So these are the different types of seals which are used to seal the internal leakages and external leakages. So some are static and some are moving along with the moving parts. There will be wear of the seals, and when there is a wear of the seal, there will be a leakages, so it has to be replaced by the new one. So different types of seals are O type, U type, V type, T type, piston rings, piston cup packings. These are different types of seals which are used in the hydraulic systems. Thank you.